Hello everyone, welcome back to this amazing channel of Infinity Learn by Sri Chaitanya, and I'm your host and host, and you all call me AV, and I'll be hosting you for this mysterious world of chemistry. And guys, as you know that from yesterday itself we have started with a series known as Chak De, and in this series what we are doing is we are covering every chapter in one single shot or in one single video. So again I welcome you all to this Chak De series of NEET 2022, and the first chapter that I am discussing with all of you is chemical bonding, one of the most important and beautiful chapter I must say. ये बहुत प्यारा chapter है guys, and not only organic, not only inorganic, even in physical chemistry this chapter plays a very important role. And yes, इस chapter का और एक extension जो मिलता है वो है coordination compounds. तो yes, ये chapter बहुत से chapter को enclose करता है, and as I said it's very much beautiful chapter. Good afternoon Sukumar, welcome to this series. So guys, as I said that my name is AV, you all can call me AV, as simple as that. And yes, you are into the Chak De series on this amazing platform of Infinity Learn by Sri Chaitanya. Okay, yeah, one more thing. If you visit to a platform that is infinitylearn.com, and if you want to buy some products, be it IELTS, that is mock test, or being any test series or doubt solving app, or getting enrolled in the live class session, okay, if you use this code AMAN40, you are liable to get directly 40% instant discount on whatever amount that particular product is. So for any product, use Aman40 as a coupon code and you will get instant 40% off of any product. So yeah, let's get started. So start करने से पहले let us see exactly what are the contents that we are going to see in this entire chapter, and I'll try to complete entire thing. So the first will be starting with introduction, followed by Lewis symbol, then ionic bond, and in ionic bond I have decided, welcome Avni. Okay, in ionic bond I have decided to discuss what is how formation of ionic bond takes place, then what is lattice energy, and then Born-Haber cycle. Basically lattice energy हम directly calculate नहीं कर सकते, okay, we cannot calculate directly lattice energy, that's why we need to understand Born-Haber cycle. Okay, and then last one, the properties of ionic compound. This is a theory, I'll just read it. Then come covalent bond. What are covalent bonds, what are the types of covalent bond, and all those stuffs. Then properties of covalent compounds. Okay, then coordinate bond, and then yes, this is one of the important segment. Let me give this thing a 3-star or a 5-star as a matter of fact. ये सबसे ज़्यादा important concept होने वाला है, ठीक है, because if you understand this concept, आगे के बहुत से problems, आगे के बहुत से concept easy हो जाएंगे. Okay, perfect. Proceeding further, once I complete this entire content, there will be a 2 minutes of break. Okay, we'll be taking a break once I complete this session. Then we'll be starting with the next session today itself. Break in the sense just a 2-minute break. Then in the next session we will be discussing formal charges, Fajan's rule, resonance, bond parameters, and in bond parameters also guys, I'll be just discussing in details bond angle. सिर्फ ज़्यादा से ज़्यादा discussion कौन सा होगा, bond angle का. Welcome Mansi. Okay, then Sidgwick and Powell theory. Depending upon Sidgwick and Powell theory, there was VSEPR theory, जिसको नाइलोमन गिलिप्सी में advance किया था. Okay, it was first given by Sidgwick and Powell, which was advanced by what? Which was advanced by Nyloman Gillespie. Okay, so yes, once we complete this content, okay, then again there will be a 2-minute break, and then we'll be jumping in the last session, that is VBT, valence bond theory. Then depending upon, to remove the drawbacks of VBT, we'll be discussing hybridization, then we'll be discussing dipole, then molecular orbital theory, and last we'll be ending up with hydrogen bonding. Okay, clear? Sure. So yeah, let's get started, and we'll be getting started with introduction. Whenever I use this word chemical bonding, okay, whenever I use this word chemical bonding, there are 3 things that should come in your mind. The first thing is, what is a chemical bond, right? The first thing that should come in your mind is, what is a chemical bond? And the second thing, for what purpose this bonding takes place, what is the reason for this bonding, किस वजह से bonding हो रहा है, इसका reason जानना है. Okay, clear? Then third thing, what are the types of bond? Okay, third thing, what are the types of bond? Welcome Teja, good afternoon. Okay, so these are the 3 things that should come in your mind, and welcome Aarti. And we'll be discussing one by one what is a chemical bond, and then what is the reason for the bonding, and the last but not the least, what are the types of bonding. ओके तो ये तीनों चीज़ें हम एक एक करके डिस्कस करते हैं. व्हाट इज अ केमिकल बॉन्ड? इट इज नथिंग बट अ फोर्स ऑफ अट्रैक्शन बिटवीन टू और मोर एटम्स और आयंस विच होल्ड देम टुगेदर इन अ मॉलिक्यूल और अ आयन. ओके क्या है ये एक जस्ट फोर्स ऑफ अट्रैक्शन है. ओके इट इज जस्ट अ फोर्स ऑफ अट्रैक्शन बिटवीन टू एटम्स और अ मॉलिक्यूल और अ आयन which holds the atom or which holds the atoms or ions in a molecule. So that's the simple thing. It is the attractive force that holds two or more atoms or ions together in a molecule or ion is called what? A chemical bond. Second thing, why does chemical bonding takes place or why does chemical bonding occurs? There are two reasons for it. First one is to acquire noble gas configuration or to have complete octet. This is the first reason, that is tendency to acquire noble gas configuration or to complete its octet. Why? Basically, if I talk about noble gas, okay, if I talk about what? Noble gases. For an example, let us take helium. Let's not take helium because helium will complete duplet. So, in spite of helium, let us take neon. In spite of helium, let us take neon. I am not saying helium is not a noble gas, but it has a duplet. So let us take neon, which can be applicable to most of the elements. Okay, neon atomic number is 10. Neon atomic number is 10. Hence, its electronic configuration is 1s2, 2s2, 2p6, or you can also write its electronic configuration as 2,8. If you will see, its valence shell has complete 8 electron, and since it has complete 8 electron, this neon or any noble gas, as a matter of fact entire noble gas will have complete octet. Okay, valence shell electron will have, valence shell will always have 8 electron, that means their octet will be complete. So for that reason, each and every gaseous or noble gases are what? Inert, and due to this inertness they exist as monoatomic, that means they do not form any bonding. Rather on the other hand, if you will see sodium, chlorine, hydrogen, okay, then there are so many elements and molecules which does not exist in their atomic state, monoatomic state. They always exist as di or polyatomic state. The reason is what? The reason is what? To gain what? Octet. For an example, Na, its electronic configuration is 281, combines with chlorine, whose electronic configuration is 287. Okay, I know it is Cl2, but I am not writing Cl2 over here. Just assume that it is combining only one chlorine, or let us make it half to be very specific. Now what will happen? This sodium will give away its electron to chlorine. This sodium will give away its electron to chlorine, and they will form sodium plus and Cl minus ion. Now if you will see, now individually if you will see, the electronic configuration is 2,8. Now see, octet is completed, valence shell has 8 electron, and second one is what? 2, 8, 8. Again see, valence shell electron has 8, valence shell has 8 electron, right? And hence can I say that they have completed their octet? Yes, perfect. So yeah, that is the first reason, tendency to acquire noble gas configuration or to complete its octet. The second reason is the tendency to have maximum stability and minimum energy. Energy and stability are inversely proportional to each other, and that's why we say that maximum stability and minimum energy. Okay, to explain you this thing, let us just assume that there are two atoms which are at infinite distance. These are two atoms which are at what? Infinite distance, and since it is at infinite distance, what we can say is the energy between these two atoms, okay, the energy between these two atoms will be, or the interaction between these two atoms will be what? 0. And since it is 0, the potential energy will be equal to what? 0. Okay, but what if they try to come close to each other? What if they try to come close to each other? Can I say that at this particular point the force of attraction is increasing and the force of repulsion is decreasing? And since force of attraction is increasing, we know that attractive forces bring stability, whereas repulsive forces brings instability. And since they are approaching to each other, can I say that attractive forces is increasing? And can I also say that since attractive forces is increasing, that means the stability is also increasing, and hence energy will be decreasing. Okay, so there will be a moment when this two particular molecule will be as close as possible. There will be a moment when this two molecule will be as close as possible. So at this particular time, can I say that there will be an attractive forces between the electron of the first molecule or the first atom and the nucleus of the second atom? Vice versa is also the same, and there will be a repulsion between the electrons and nucleus, right? Sure. There will be a time where this two atom will be as close as possible. This two atom will be what? As close as possible, and this distance is the maximum closest distance that a two atom can approach each other. This is what maximum closest distance where two atoms can approach each other, and at this particular point, the force of attraction is maximum. Okay, now if you try to bring close, okay, अब यहाँ से और एटम को क्लोज करने की कोशिश करोगे तो क्या होगा? रिपल्सिव फोर्सेस ओवरकम कर लेंगे अट्रैक्टिव फोर्सेस को, और जैसे रिपल्सिव फोर्सेस अट्रैक्टिव फोर्सेस को ओवरकम कर लेंगे, द अनस्टेबिलिटी विल स्टार्ट राइजिंग एंड द मॉलिक्यूल विल नॉट सस्टेन. और अगर वैसे मॉलिक्यूल को सस्टेन कराना है तो आपको एनर्जी सप्लाई करनी पड़ जाएगी. ठीक है, श्योर. लेट अस अंडरस्टैंड द सेम थिंग विद द हेल्प ऑफ अ ग्राफ. ओके, एंड दिस इज द ग्राफ. इफ विल सी एट एन इनफाइनाइट डिस्टेंस, if you'll see at an infinite distance, okay, here at an infinite distance, okay, potential energy is approximately equal to 0. अब क्या कर रहे हैं हम? अब ये जो दो मॉलिक्यूल है वो बहुत दूर है, बहुत दूर रखे, इनफाइनाइट डिस्टेंस पे रखे. नाउ व्हाट इज हैपनिंग? इट इज अप्रोचिंग, they are approaching to each other, and since they are approaching, can I say that attractive force is increasing and energy is decreasing? So see, energy is decreasing, एनर्जी डिक्रीज हो रहा है. कैन आई से दैट देर विल बी अ पॉइंट, ओके, देर विल बी अ पॉइंट जिसके आगे, ओके, जिसके आगे ये दो एटम्स को आप नज़दीक नहीं ला सकते या ग्रुप ऑफ एटम्स को नज़दीक नहीं ला सकते. सो दैट पर्टिकुलर पॉइंट, ओके, दैट पर्टिकुलर पॉइंट इज नोन एज व्हाट? दैट पर्टिकुलर पॉइंट, यहाँ पे क्या आएगा? मिनिमम एनर्जी. बियॉन्ड दिस, इफ विल ट्राई टू ब्रिंग क्लोज two atoms to each other, the repulsive forces will overcome and energy will have a sudden increase. So see, इसके आगे अगर लाने की कोशिश करोगे तो क्या होगा? एनर्जी बढ़ना चालू होगा और एक्सपोनेंशियल इंक्रीज होगा. सी, राइट, एंड मॉलिक्यूल सर्वाइव नहीं कर पाएगा. दैट मीन्स मॉलिक्यूल विल बी अनस्टेबल. क्लियर? श्योर. And yes, this particular point, that maximum closest distance is known as bond length. That maximum closest distance is known as bond length, and that particular point corresponds to minimum energy. Okay, right? Welcome, Aram. Okay, so yes, that particular point is known as what? Minimum energy. Covalent bond. इसके लिए ज़्यादातर ये चैप्टर हम covalent bond पे ही डिस्कस करते हैं. ठीक है, most of the time we'll be discussing what covalent bond, some extent ionic, some extent coordinate, and some extent hydrogen bonding. Clear? श्योर. मेटालिक बॉन्डिंग सॉलिड स्टेट में पढ़ना ज़्यादा बेटर होता है, यहाँ पे इतना हम डिस्कस नहीं करेंगे, बट यस, द मेन पॉइंट ऑफ एरिया विल बी दिस. आगे बढ़ते हैं. ओके, सो कंटेंट के ऊपर वापस आते हैं. इंट्रोडक्शन इज डन, राइट? वी हैव ऑलरेडी कंप्लीटेड इंट्रोडक्शन. लेट अस स्टार्ट विद लुईस सिंबल. बहुत सिंपल है लुईस सिंबल. लुईस सिंबल में सिर्फ 2-3 चीज़ें हैं जो याद रखनी है. पहले तो ओके, पहले तो वैलेंस शेल इलेक्ट्रॉन को छोड़ के, इफ़ यू लीव द वैलेंस शेल इलेक्ट्रॉन, all other electrons are known as inner core electrons or core electrons. Okay, apart from valence shell electrons, all electrons are known as what? Core electron. Second, core electron plus nucleus is known as kernel. Core electron plus nucleus is known as kernel, and this kernel is represented with the element symbol itself. With the element symbol itself. And last but not the least, the valence shell electrons are represented by dot or cross. So let us see that thing as well. So the nucleus along with the core electron forms a positively charged kernel, as I said. Okay, this kernel is represented by element symbol. Last but not the least, the valence shell electron are represented by dot or cross. Clear? To explain you this thing, let us take sodium. What is the electronic configuration of sodium? Can I say sodium has atomic number of 11, so its electronic configuration will be 2, 8, 1. So this is known as what? Core electrons. This is known as what? Core electron. And how many valence electrons are there? 1. So I will be just drawing 1 dot. कहीं पे भी बना सकते हो, ओके, नो इश्यूज. कहीं पे भी बना सकते हो और कैसे भी बना सकते हो, बट यस, जितना सिमेट्रिकल होगा उतना अच्छा होगा. ठीक है. देन talking about aluminium, it is 13. Okay, so it is 2, 8, 3. Again, this is known as what? Core electron, and kernel is represented by element symbol itself. So 3 electrons means how many dots? 3 dots. 1, 2, 3. Right? Chlorine is 17. Right, chlorine is what? 17. then it is 2, 8, 7. That means how many electrons? 7 electrons. So that 7 electrons can be drawn in this way: 1, 2, 3, 4, 5, 6, and 1 is 7. Clear? Sure. Welcome Marg. Hello. So this is the Lewis symbol, as simple as that. ज़्यादा details में नहीं जाते इसके. So we have completed with introduction, we have completed with Lewis symbol. Now talking about ionic bond. Okay, so if I talk about ionic bond, okay, talking about ionic bond, okay, how to write helium talks Aarti. See Aarti, it's very simple. अगर मैं helium लूँ, its electronic configuration is 2, that means its valence shell and core electron is equal to what? 2. So hence helium can be drawn in this way, 2 dots, or I can just show it like this as well, 2 dots, or you can put 2 cross as well. Okay, clear? Talking about ionic bond, what is an ionic bond, guys? Ionic bond is a force of attraction between two oppositely charged ions. Okay, the force of attraction, ionic bond is what? It is a force of attraction between two oppositely charged ions, like sodium plus and chlorine minus ion. The bond that exists between these two ions are known as what? Ionic bond. Why? Because it's a force of attraction between a cation and an anion. Clear? Sure. Let's proceed further. Talking about the formation of ionic bond. Ionic bond is formed when cation can form easily, and cation can form easily if it has less ionization energy. So low ionization energy will favor ionic bond formation. Second one, an anion can form, it has more electron gain enthalpy. Anion कैसे बनता है? जब electron gain enthalpy ज़्यादा हो. So high electron gain enthalpy. Talking about the last one, lattice energy. What is lattice energy? It is the amount of energy required to break 1 mole of an ionic compound into its gaseous ion, or it is the amount of energy released when 1 mole of compound or crystal is formed from its gaseous ion. Okay, और ये जितना ज़्यादा होगा उतना अच्छा है. ठीक है गाइस, ये जितना ज़्यादा होगा उतना अच्छा है. So yes, these are the 3 things that you should remember for the formation of ionic bond. अगर ये फेवर कर रहा है तो ionic bond बहुत strong बनेगा. Then talking about lattice energy, मैंने already definition discuss कर दिया. It is the amount of energy released when 1 mole of a crystal is formed from oppositely charged gaseous state. जब बन रहा है तो it is energy released. Okay, जब ionic crystal, if you define it as formation of ionic compounds or a crystal, then it is amount of energy released. If it is breaking, then amount of energy supplied. Okay, so energy required to break, that means energy is supplied. याद रखना, बनेगा तो भी gaseous state से ही बनेगा, and जब dissociate होगा तो भी gaseous state में ही dissociate होगा. ठीक है, please remember that thing. Okay, if ionic compound is formed, it is formed from its ions in gaseous state. If an ionic compound breaks, again it breaks into its ion into its gaseous state. Okay, so depending upon this thing, lattice enthalpy, the problem with the lattice enthalpy is we cannot calculate it directly. Hence we use 2 things. First one is Hess law and the second one is Born-Haber cycle. We apply Hess law on Born-Haber cycle. What is Hess law? Hess law says that कि कोई भी रिएक्शन आप सिंगल स्टेप में करो या उसी रिएक्शन को जितने चाहिए उतने स्टेप में करो, बट द चेंज इन द एंथैल्पी विल रिमेन सेम. एनर्जी रिक्वायर्ड फॉर सिंगल स्टेप और मल्टीपल स्टेप रिमेन्स द सेम. तो ये हो गया Hess law. What is Born-Haber cycle? We'll be understanding Born-Haber cycle for this particular reaction. Here what I have written is enthalpy of formation. Here what I have written is what? Enthalpy of formation, which says that when 1 mole of a compound is formed from the element in their standard state. Okay, when 1 mole, it has to be always 1 mole when the element in their standard state. So as I said, ये प्रिपेयर करने के लिए मुझे सोडियम आयन चाहिए गैसियस स्टेट में, क्लोरीन अनायन चाहिए गैसियस स्टेट में. सो यहाँ पे मेरे पास क्या है? सोडियम सॉलिड. सो फर्स्ट आई विल कन्वर्ट दिस थिंग. ओके, फर्स्ट वेट अ सेक. यप, फर्स्ट आई विल कन्वर्ट दिस थिंग इनटू सोडियम गैस. पहले तो सोडियम गैस में कन्वर्ट करेंगे, एंड देन दिस सोडियम गैस विल कन्वर्ट इट इनटू एन आयन. यही प्रोसेस होगा. पहले तो सॉलिड से गैस में ले आओ, एंड देन गैस से क्या करो? उसको आयनाइज कर दो. एनर्जी इन्वॉल्व्ड, ओके, एनर्जी इन्वॉल्व्ड ओवर हियर, सॉलिड टू गैस, कैन आई से इट इज एंथैल्पी ऑफ सब्लिमेशन. gas to ion, okay, gas to ion, can I say it is enthalpy of ionization. ये किसका हो गया, सोडियम का, right? Then comes chlorine. First of all, there are two chlorine, we need only one, okay. For this thing what we do is we just need only one, okay. So can I say that I have to dissociate this diatomic into monoatomic, that is chlorine gas, and then I have to ionize it and make it an anion of it, right? Now to break this diatomic molecule into monoatomic, it is known as enthalpy of atomization. It is known as what? Enthalpy of atomization. Then I have to add electron into it, so it is an electron gain enthalpy, right? Now what we have to do, you have to just add this thing, and the moment you add this thing you will get this, right? And which is lattice enthalpy, and according to Hess law, delta HF, let me write it over here, somewhere over here, yes. According to Hess law, okay, the energy change in this reaction or the energy change is will be equal to what? Total. ये reaction में जितनी energy लग रही है and ये जो total energy वो क्या होगी? बराबर होगी, ठीक है. So it is summation of enthalpy of sublimation plus enthalpy of ionization plus atomization enthalpy plus electron gain enthalpy plus lattice enthalpy, right? And from this equation you can easily calculate what? Lattice enthalpy, because rest we can calculate easily. Clear? Sure. Perfect. Great. So that is what formation of sodium chloride. Okay, I hope guys you are getting it. If you are not getting any point, please make sure that you are going to comment it in the chat box so that I can help you out with that. Okay. Proceeding further, factors that affect lattice enthalpy. Okay, what are the factors that affect lattice enthalpy? First of all, okay, to form an ionic compound, their electrostatic force of attraction, should be more, and hence force of attraction, electrostatic force of attraction is directly proportional to lattice enthalpy. This electrostatic force of attraction, okay, will be more if the charge on ions are more. So it is directly proportional to what? Charge on ions, right? Which is again proportional to the distance or the size of an atom. More the distance or more the size of the atom, less will be the lattice enthalpy, and hence it is inversely proportional. Okay, so this is the thing. Okay, इतना भी याद रहेगा तो ट्रस्ट में lattice enthalpy के काफ़ी सारे क्वेश्चन सॉल्व हो जाएंगे. लेट अस स्टार्ट विद द फर्स्ट वन, चार्ज ऑन आयंस. ठीक है, चार्ज ऑन आयंस को हम कैसे समझते हैं, ध्यान रखना. +1 -1 के बीच में जो फोर्स ऑफ अट्रैक्शन होगा दैट विल बी लेस देन +1 -2, और यू कैन ऑल्सो टेक इट एट +2 -1. either way, vice versa is also applicable. Okay, then it will be more than +2 -2 and so on. Just to give you an example, let us take sodium fluoride, magnesium fluoride and aluminium trifluoride. So यहाँ पे +1 +2 and +3, and this is -1 -1 and -1, right? So as I said, with that particular equation, can I say that AlF3 का सबसे ज़्यादा होना चाहिए, okay, bond enthalpy, right? और basically lattice enthalpy, and then magnesium fluoride का, ठीक है, and the least one is what? Sodium fluoride. Similarly, if I take one more example, see +1 +2 +3, okay, -2 -2 -3 -2. Again, what will be the order? Clear? Sure. Last one, right? See, +1 -1 +2 -2 +3 -3 +4 -4, right? Again same thing. So क्या होगा, कार्बाइड का ज़्यादा, then nitride, then oxide, and the last one will be what? Fluoride. Clear? So as I said, charge on ions की भी on the basis of charge on ions, this is the concept, and talking about the size of ions, it is inversely proportional. As I said, it is inversely proportional to what? Lattice enthalpy, right? So if we'll say this order, see, size keeps on increasing, right? Size keeps on increasing, and hence bond enthalpy, or basically lattice enthalpy keeps on decreasing. Okay, lattice enthalpy keeps on decreasing. Second, again if you'll see, beryllium is smaller than magnesium, which is smaller than calcium, strontium and barium. Again what is happening? Size is increasing, hence lattice enthalpy will decrease, as simple as that. Clear? So these are the factors that affect what? Lattice enthalpy. Clear? Properties of ionic compounds, they are crystalline in nature, hardness, okay, they are hard and brittle in nature, okay, high melting and boiling point, then highly soluble in polar solvent, less soluble in non-polar solvent, then conducts electricity in fused state or in their aqueous solution. Okay, last one is important, ये वाले पे please ध्यान देना. Bonds are non-directional in nature. इसका बहुत simple सा मतलब है. Suppose there is an cation over here and there is an anion over here. Is there any direction required for their force of attraction? Is there any direction required? Answer is no, there is no direction required, because even if this negative charge is over here, they will have a force of attraction. Even if this negative charge is over here, they will have force of attraction. Obviously depending upon the distance, okay, depending upon the distance, the force of attraction will increase or decrease. But the point over here is they do not have a direction for their force of attraction, and since they do not have a particular direction, they do not have any shape or geometry. Okay, do not form any shape or geometry. Okay, they have a crystalline structure, but they do not have shape or geometry, which we will be seeing in a covalent compound. Okay, clear? And that is the reason this cannot show isomerisms as well. Okay, proceeding further, ये हो गया, ये हो गया, ये हो गया. Now coming upon to covalent bond. What is covalent bond? The bond which is formed by mutual sharing of electron. Okay, the bond which is shared by what? Mutual sharing of electrons. So that is nothing but covalent bond. And covalent bond जिस भी compound में होगा, that is known as what? Covalent compound. Okay, clear? आगे बढ़ते. Favorable conditions for covalent bond formation. सबसे पहला चीज, the electron negativity difference between the both the atoms should be as small as possible. So that is the first pointer, small electronegativity difference. Okay, talking about the second pointer, individual electronegativity should be high. Both the atoms should have more electronegativity, something like this, high electronegativity, right? Last but not the least, the valence shell electron should be more than 4 or more than 4, like 4, 5, 6, 7. And if this justify this condition, covalent bond formation will take place. Types of covalent bond, it is single, double and triple bond, we all know it. Between hydrogen, what exists is a single bond. Between oxygen, what exists is a double bond, and between nitrogen, what exists is a triple bond. Okay, clear? Another type of covalent bonds are polar covalent bond and non-polar covalent bonds. Okay, polar covalent bonds and non-polar covalent bonds. Polar covalent bond whose dipole moment is not equal to 0. That means it has some polarity, right? And talking about non-polar covalent bonds, its dipole moment will be equal to what? 0. Like for an example, hydrogen, hydrogen. The bond that exists between them is what? Non-polar. Why? Because both hydrogen have same electronegativity, hence electron is not shifted towards either side. Talking about over here, HCl. This is non-polar. This is polar covalent compound or polar covalent bond. Why? Because electronegativity of halogen is more, hence the electron will be shifted more towards halogen, and hence it will get a partial negative and partial positive charge. And since the dipoles are created, it is known as what? It is known as what? Polar covalent bond. Clear? Talking about, again coming upon to this particular part. So we have discussed this and covalent bond. Now we will be discussing the properties of covalent bond. Talking about the properties of covalent bond, physical state, it exists in solid, liquid and gases. All the state it exists, light. Okay. Third, melting and boiling point, it is generally having low melting and boiling point. There are some exceptions like graphite and diamond. Okay, there are some exceptions like what? Graphite and diamond. Okay, clear? Which have what? High melting and boiling point. Then it is generally less soluble. It is less soluble in polar compounds or polar solvent, and more soluble in what? Non-polar solvent. Okay, that's why they do not conduct electricity in their aqueous state. But yes, there are some compounds like HCl, carboxylic acid, okay, which are soluble in water and can conduct electricity in their solution. Okay, so they are generally bad conductor of heat and electricity. Last one is very important, they are directional in nature. Why they are directional in nature? We'll discuss this thing in theories known as VSEPR theory and VBT theory. But yes, they are directional in nature. That means their bonding can take place. Okay, their bonding can take place in a particular direction. Just to give you a hint, PX cannot combine with PY. if it is px orbital and if it is py orbital, this combination is not possible because they are not in the same direction and hence bond formation will not take place. But on the other hand, px can combine with px. This combination is possible. Clear? Sure? Perfect. So we have also discussed the properties of what covalent compound. Now we comes upon coordinate bond. Coordinate bond has two things in it. One is donor atom and one is acceptor atom. There are two things. One is donor atoms and one is acceptor atom. For donor atom, you always remember it should have a lone pair. For donor atom, always remember it should have a what? Lone pair or a negative charge. Then and only it will act as a what? Donor atom. For acceptor atom, it should have maximum 6 electron. It should have maximum of what? 6 electron. Donor atom acts as a Lewis base, whereas acceptor atom acts as a Lewis acid. Remember this thing. Now depending upon this donating and accepting property, there are two important things that I wanted to share it with you all. Okay. The first one, if the donor atom, okay, if the donor atom belongs to second period, then that coordinate bond is represented as single bond, and with the charges present over it. What I am trying to say is, this is water, okay. The moment I add an acid, it gives a proton. Now what this oxygen will do, it will donate its proton, okay, and it will form a coordinate bond, and hence what will be the structure looking like? Like this, coordinate bond, but it is not shown in this way. In spite of showing coordinate bond, what we will be showing is a just single bond. Just a single bond, first of all, because here donor atom is what? Oxygen. Second important thing, their charges has to be represented. Oxygen has given electron, so hence it should have a positive charge, whereas hydrogen has accepted electron, but before that it has a positive charge. It has accepted a negative charge, hence the charge will be neutral. Okay, this is what I want, this is what I mean if I talk about this particular example. Again बोल देता हूँ, अगर donor atom, okay, if the donor atom is from second period only, then the bond, coordinate bond, is represented as single bond with charges. If it is from third period onwards, that coordinate bond is represented as a double bond. Please remember this thing, that coordinate bond is represented as what? Double bond. For an example, SO3, S double bond O, coordinated with oxygen. So in spite of showing this coordinate bond, since sulfur comes from the third period, it can be represented as this, S double bond O. So in spite of coordinate bond, it should be shown as a double bond with no charges. Proceeding further, coordinate bond is then coming upon to the very important part, that is Lewis structure of for polyatomic molecules or ions. Please ध्यान से समझना, बहुत important है. Okay, talking about Lewis structure for polyatomic molecules or ions, there are some steps to be followed. पहला step है just to know the central atom. The first and the foremost important step is what? To know the central atom. There are several ways. Okay, there are several ways that you can do. पहला वाला, okay, the first one is you can select the most electropositive atom or least electronegative atom. Okay, first वाला क्या select कर सकते हो? Least electronegative atom or most electropositive atom. Okay, second that you can select is atom which can have a tendency to form multiple bonds, which can form more than one bond. ठीक है, ऐसे एटम जो एक से ज़्यादा बॉन्ड बना सकते हैं, हम उसी एटम को क्या लेंगे? सेंट्रल एटम कंसिडर कर सकते हैं. अच्छा, जब भी मैं पढ़ाता हूँ स्टूडेंट फील लाइक कि ये दोनों होने चाहिए, नहीं, आउट ऑफ बोथ दिस टू वन कैन बी डू. और भी 2-3 पॉइंट्स हम करने वाले, बट याद रखना सारे के सारे हो ऐसा कंपलसरी नहीं है. एवरी पॉइंटर इज नॉट रिक्वायर. इफ एनी वन इज एप्लीकेबल यू कैन डिस्कस, यू कैन जस्ट टेक इट. ओके, क्लियर. टॉकिंग अबाउट द थर्ड वन, इट शुड बी लीस्ट इन नंबर or it should have a maximum size or maximum atomic number. Okay, so these are some of the ways in which you can select your central atom. So atom with having highest atomic number or largest size or least in number, या तो कम हो तो हम उसमें क्या करेंगे? सेंट्रल एटम सेलेक्ट कर सकते हैं. फॉर For an example, let us take H2SO4. In this H2SO4, okay, in this H2SO4, if I am not mistaken guys, you all are going to select central atom as sulfur. Central atom as sulfur. Why? सबसे पहले तो size सबसे बड़ा. It is a third period element, that means the size will be maximum, right? The size will be what? Maximum. First thing. Second, it has more electronic atomic number as well. Atomic number भी इसका क्या है? सबसे ज़्यादा है. Clear? Sure. और क्या क्या चीज़ें एप्लीकेबल हो सकते हैं? लीस्ट इन नंबर. हाइड्रोजन 2 एटम है, ऑक्सीजन 4 एटम है, बट सल्फर 1 ही एटम है, सो लीस्ट इन नंबर भी है. ठीक है, क्लियर? सो या दिस इज व्हाट द सिलेक्शन. ओके, एंड याद रखना जब भी आप सेंट्रल एटम सेलेक्ट करोगे तो हाइड्रोजन एंड फ्लोरीन को कभी मत सेलेक्ट कर लेना, बिकॉज दे कैन फॉर्म ओनली वन बॉन्ड एंड ये हमेशा टर्मिनल्स पे ही मिलेंगे, मॉलिक्यूल के बीच में नहीं मिलेंगे. ठीक है, देयर आर वेरी लेस केसेस वेयर हाइड्रोजन आर डायरेक्टली बॉन्डेड टू व्हाट सेंट्रल एटम. Okay, but yes, there are cases, but yes, hydrogen and fluorine can never form what central atom. Talking about drawing the symmetrical skeleton, first of all select the central atom. यहाँ पे central atom carbon होगा, because what is the reason over here? Less electronegative as compared to oxygen and least in number. Similarly nitrogen and H2SO4 का sulfur, and you have to draw this thing in a symmetrical way. So carbon dioxide, can I draw it in this way? Oh, sorry, I am directly drawing carbon dioxide itself. We have to draw symmetrical structure. Now symmetrical structure can be anything. बीच में क्या रख दिया? Central atom. Now you can have symmetrical structure like this, or you can draw symmetrical structure something like this. Again I am drawing double bond. Oxygen and oxygen. This is a symmetrical structure. What about NH3? Nitrogen in middle. Can I draw 3 hydrogen at 120 degree to make it symmetrical? Similarly H2SO4, how we can draw? Sulfur. There are 4 oxygen, 1, 2, 3, 4, right? Symmetrical. And there are 2 hydrogens as well, and that hydrogen will be at the terminal, so you can add it to any oxygen. I am just making it symmetrical like this. So this is the case. Clear? Sure? Perfect. So this is the second step, but yes, there is something related to oxygen you should know. Oxygen will never form bond with itself. The first thing that you should know is oxygen will never form bond with itself, except it is ozone or peroxide or superoxide or oxygen molecule itself. ये चारों मॉलिक्यूल के अलावा ऑक्सीजन का बॉन्ड नहीं मिलेगा. ऑक्सीजन विल नेवर बॉन्ड विद इटसेल्फ अपार्ट फ्रॉम ऑक्सीजन मॉलिक्यूल इटसेल्फ, ओजोन मॉलिक्यूल, peroxides and superoxides. ठीक है. सेकेंड थिंग, इफ ऑक्सीजन आर प्रेजेंट एट द टर्मिनल, ओके, इफ ऑक्सीजन आर प्रेजेंट एट द टर्मिनल, इसका मतलब देखो ये है टर्मिनल ऑक्सीजन, दिस इज टर्मिनल ऑक्सीजन, दिस इज टर्मिनल ऑक्सीजन, this is terminal oxygen. So whenever oxygen is present at the terminal, okay, it will form a double bond. In most of the cases it forms double bond, but yes, if it is a second period, if the central atom is from second period, then it depends, okay, but yes, in most of the cases it will form what? A double bond. It will form a double bond. And if oxygen is present in between, like this oxygen is in between, दिस ऑक्सीजन इज इन बिटवीन, ओके, ये बीच में ऑक्सीजन है, ये हमेशा क्या करेंगे? सिंगल बॉन्ड बनाएंगे. तो अगर ये दो कॉन्सेप्ट भी आप लगा लो तो यहाँ पे डबल बॉन्ड, यहाँ पे डबल बॉन्ड, ये सिंगल बॉन्ड्स बनाएंगे और ये सिंगल बॉन्ड, तो ये बन गया स्ट्रक्चर ऑफ H2SO4. सो इजी एंड क्विक, ओके. So yes, that's what I said. Oxygen atom do not form bond with each other except in the case of oxygen gas, ozone, peroxide and superoxide. Okay, if oxygen is in middle, it will form single bond. If it is at corner of the molecule, it forms double bond. Okay, in oxy acids, hydrogen and oxygen will always form a bond, or hydrogen is always bonded to oxygen apart from only two things, H3PO3 and H3PO2. So this is what step number 2. Talking about step number 3, you need to calculate the total number of valence electron, जिसको हम V से designate करेंगे. Then we need to calculate the required electron, जिसको हम R से represent करेंगे. Then shared pair of electron निकालना है, and unshared pair of electron, that is S and U, that can be given as R minus V and V minus S. And the last one is bond pair and lone pair of electron. So S by 2 is the bond pair electron and U by 2 is known as what? Lone pair of electrons. Okay, clear? So ये concept है. अब ये कॉन्सेप्ट के बाद आता है क्वेश्चन. सो लेट्स बिगिन गाइस कि हाउ टू सॉल्व दिस क्वेश्चन. अब चीज़ें मज़ा आएंगी, ठीक है. हमने जो जो चीज़ें पढ़ी है उसको अप्लाई करने का मौका मिलेगा. क्लियर. सो लेट्स गेट स्टार्टेड विद द फर्स्ट वन. CH4. आई नो दिस इज़ अ वेरी सिंपल मॉलिक्यूल, बट येस इसको पहले हम प्रूव करेंगे. ओके, फर्स्ट विल बी प्रूविंग दिस पर्टिकुलर कॉन्सेप्ट एंड देन थोड़े से कॉम्प्लेक्स मॉलिक्यूल भी डिस्कस करेंगे. सो लेट अस सी अपने को क्या चाहिए. VRSU bond pair and lone pair. These are the things that we required. ओके, पहला क्वेश्चन है तो मैं पूरा प्रॉपरली सॉल्व करूंगा इसको. ठीक है. सी कार्बन वैलेंस इलेक्ट्रॉन इज 4, हाइड्रोजन वैलेंस इलेक्ट्रॉन इज 1, दैट टोटल 4 हाइड्रोजन, so 4 that goes to 8. So valence electron is 8 in methane CH4. Second is required electron. Carbon completes, carbon require octet, so the carbon require what? Octet, so it require 8 electron for complete octet. Okay, whereas hydrogen require 2 electrons, or hydrogen is a duplet. Carbon becomes octet, carbon wants octet set, whereas hydrogen want duplet. So 2, how many hydrogens are there? 4, so goes to 8, 8 plus 8 16. S is what? R minus V. So 16 minus 8 is what? 8, right? U is what? V minus S. So V and 8 minus 8 is how much? 0, right? Bond pair is what? U by 2. Sorry, S by 2. Bond pair is what? S by 2. So what is at 8? 8 by 2 is 4. Okay. What is lone pair? U by 2. It is U by 2. U is 0, hence it is 0, right? Now first step, select the central atom. Here central atom will be carbon. Second step, write a symmetrical structure. Hydrogen, 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 hydrogen. How many bond pair electrons are there? 4 bond pair electrons. So can we place bond pair electrons like this? See, 1, 2, 3, 4. So this is the structure, right? This is what? The structure. Clear? समझ में आया guys? I hope you have understood this VRSU technique as well, right? Perfect. आगे बढ़ते हैं. H2SO4. Again, V. That means 2 hydrogen and it has 1 electron in the valence shell. Plus sulfur has 6 electron in the valence shell. Oxygen has 6 electron in the valence shell. Multiply by 4. So it goes to how much? 6 4s are 24, right? And 6 5s are 30. This is 32, right? R, hydrogen requires duplet, so 2 into 2. Rest sulfur and oxygen requires octet, so there are total 5 atoms into 8. So 5 8s are 40. 40 plus 4 is 44. S. Okay. S is what? R minus V. What is R minus V? 44. 44 minus 32 is how much? 12. Right. Then U is what? V minus S. 32 minus 12 is how much? 20. What is bond pair? It is S by 2. S is how much? 12. 12 by 2 is how much? 6. Right. And what is lone pair? What is lone pair? 20 by 2. That is U by 2. That is 10. So again, central atom, sulfur. Side atoms, oxygen. And then 2 hydrogens. We have already drawn this structure, right? Now we need to place lone pair. Now we need to place what? Lone pair and bond pair. How many bond pair are there? 6 bond pair. So place 1, 2, 3, 4, 5, 6. Okay. How many lone pair are there? 10. 10 lone pairs need to be placed. There are 4 electrons already with oxygen. 5, 6, 7, 8. So 2 lone pairs get occupied. Due to symmetry, can I place 5, 6, 7, 8? So out of 10, 4 are gone. Remaining 6. There are 2 oxygen. There are 2 oxygen, right? That means right? Clear? Now please make a note of one thing, guys. please make a note of one thing. Oxygen has 6 electron in valence shell and it uses that electron in bond formation. If you will see this oxygen, there are 2 lone pairs which are not participating in the bond, but there are 2 electrons, which is sharing their electrons, right? So can I say that it forms a proper covalent bond? It forms a proper covalent bond. But fixate on this oxygen. It has total 3 lone pairs. That is 3 lone pair. That is equal to 6 electron. And oxygen has 6 electron in their valence shell. By default oxygen में क्या होता है? 6 electron होता ही है. That means can I say that यहाँ पे जो bond form हुआ है वो oxygen ने अपना electron नहीं दिया है. Oxygen has not given its electron, okay, in bond formation. That means वो electron आया कहाँ से होगा? सल्फर के तरफ से, राइट? सल्फर के पास आउटर मोस्ट शेल में कितने होते हैं? 6. देखो 4 ही दिख रहे, तो ये रहा 5th वन, राइट? सो कैन आई से दैट सल्फर हैज डोनेटेड इलेक्ट्रॉन. दैट मीन्स व्हाट? कोऑर्डिनेट बॉन्ड जैसा दिखेगा ये. सल्फर हैज डोनेटेड इलेक्ट्रॉन्स. सिमिलरली ड्यू टू सिमेट्री कैन आई से सल्फर हैज डिनोटेड इलेक्ट्रॉन. यहाँ पे सिंगल बॉन्ड, सिंगल बॉन्ड, सिंगल बॉन्ड, सिंगल बॉन्ड, तो ये रहा स्ट्रक्चर. सिंस सल्फर is showing a coordinate bond formation and it belongs to third period, can I say this coordinate bond can be converted into double bond? Answer is yes, we can do that. Clear? Perfect. So here H2SO4 का Lewis structure. Clear? I hope guys you must have understood this particular structure as well. Okay. Then HClO4 is again the same thing. Let us do VRSU. So V is how much? It is 1 plus it is 7 plus 4, 6 4s are 24, that is equal to how much? 8, and 8 plus 4 is 32. Then R, H completes duplet, whereas all completes what? Octet. So it is again, wait a sec, yeah, so there are total 5 atoms and 5 8s are 40, so it goes to 42. Okay, then S is what? R minus V, and R minus V is what? 10. Then U is what? V minus S. So V minus S is how much? 22, right? And what is bond pair? It is S by 2, that is equal to 5. And what is lone pair? It is 22 by 2, that is equal to 11. Again, chlorine, highest atomic number, right? And biggest size and less electronegative, right? Oxygen should be placed, there are 4 oxygen, 1 2 3 4, it's an oxy acid, so 1 hydrogen over here itself. Okay, now let us start placing the bond pairs. Okay, so talking about bond pairs, there are total 5, 1 2 3 4 and 5. Got it? How many lone pairs are there? 11 lone pairs. Okay, 11 lone pairs, 1 2, right? There are only 2. How many remains? 9, and there are 3 oxygen. That means how much? Each oxygen will have 3. So 1 2 3, 1 2 3, 1 2 3. Now again if you will see, all 6 electrons of oxygen are intact with oxygen itself. Then can I say that chlorine has donated its electron to form a bond, and since it has donated its bond, it can be represented as covalent bonds. It can be represented as what? Covalent bond, and hence its structure, all this covalent bond will get converted to a double bond structure. Okay. In the same way, Marshall's acid, I am not going to do VRSU technique, I am just showing you the structure. Sulfur, there are 2 central atoms over here. Each central atoms, there are 8 oxygen, that means each central atom will have 4 oxygen, 1 2 3 4, 1 2 3 4, and there are only 2 hydrogens. Out of symmetry I am placing it over here. So there is an peroxy linkage, please remember this thing, there is an what? Peroxy linkage. Clear? And yes, you can draw this structure, you will get this structure, you can now practice it. I am just giving you this structure. Okay, talking about pyrosulfuric acid, again now if you will see, there are 2 sulfur and 5, that means 1 oxygen is been shared. So its structure will be something like this: H O S O S O H you can convert this coordinate bond into double bond itself. Okay. Then coming upon to H3PO3, H3PO3, H3PO4, H3PO3 and H3PO2. Please remember this structure. Try to remember this structure as well. This is very crucial structure for you all. Okay. This is one of the structure. Then H3PO3 is this structure. Okay, where hydrogen is directly bonded to central atom, and H3PO2 is this structure. This is hydrogen over here and this is hydrogen over here. So please try to remember this structure. These structures are really very important. ये structure really बहुत ज़्यादा important है. Please make sure that you are actually remembering this structure. H3PO3, okay, phosphoric acid, phosphorus acid, hypophosphorus acid. Okay, clear? Please try to remember this structure. Okay, so yes, so I hope we have completed the first session and it's time to break. But yes guys, अगर अभी तक like नहीं किया है वीडियो को, please make sure that you are going to like the video, comment on video as well. Okay, and yes, subscribe नहीं किया तो please make sure you subscribe it and do share it with your friends. We will be just back in 2 minutes. Okay, so your time starts now. ठीक है. Okay guys, so the break time is gone now. I hope आप लोगों ने like कर दिया होगा वीडियो को, and yes, subscribe our channel. If you are new to the channel yet not subscribed, please make sure that you are going to subscribe your channel subscribe our channel as well. And yes, do not forget to press the bell icon to get all the recent updates of all the sessions that we are going to conduct in this Chak Day series. Okay, so yeah, let's start with the next content part of it. As I said, this particular segment we will be discussing formal charges, very easy concept, Fajan's rule, resonance, bond parameters, Sidgwick and Powell theory, and VSEPR theory. Okay, let's try to be as fast as possible in this session. Talking about formal charges, we'll directly do the calculation. Okay, we'll directly do the calculation, not going into that much of theory. Formal charges can be easily calculated by this. Formal charge will be equal to V, that is valence shell electron. This is lone pair. One of the mistake that student does is if there are two lone pairs of electron, okay, if there is how much, two lone pair of electron, they just take it as 2, but what you have to do it multiply by 2, because one lone pair consists of 2 electrons. So 2 into 2 becomes how much electrons? 4 electrons. So please make a note of it guys, please make a note of it. You don't have to count number of lone pairs, it is a total number of electrons in a lone pair. If there are 3 lone pairs, that means 6 electrons. If there is 1 lone pair, that means 2 electrons. Okay, and the last one is half into bond pair electrons, or simply the bond formed और simply the bond formed. कितना फॉर्म किया है बॉन्ड उसने वो काउंट कर लो, या बॉन्ड लाइक वन बॉन्ड इज इक्वल टू 2 बॉन्ड पेयर इलेक्ट्रॉन्स, राइट. सो either count the number of bonds, that's it, or you can count the number of electrons in the bond and then divide it by 2. It's one and the same thing. Clear? Chalo, proceeding further, we'll be just discussing one question. So let's get started again. So हो जाए शुरू guys for one particular question, H2SO4, but this is not the question. Question मैं बनाऊंगा यहाँ पे. So question is, let me draw the structure. Okay, so we need to calculate the formal charge on this atoms 1, 2 and 3, which are represented by what, 1, 2 and 3. We need to calculate the formal charge on this atom. So let us start for the first one. Okay, so valence electron, how many valence electrons are there? Oxygen has how many valence electrons? 6. Then okay, then what we need to calculate, lone pair. How many lone pairs are there? 2. There are 2 lone pairs. 2 into 2 is how much? 4 electrons. How many bonds it has formed? 2. Or how many bond pair electron? 4. So you can take directly 2, or you can take 4 by 2 according to the formula, but this will be ultimately equal to what? 2. So 6 minus 4 minus 2, can I say it is equal to 0? Hence it does not have any charge. Talking about sulfur, that is the second atom over here. Okay, talking about sulfur. Sulfur again has how many valence shell electrons? 6. How many lone pair? 0. As you can see, there is no lone pair over there. How many bond it has formed? 1, 2, 3, 4. There are 4 bonds that has been formed. How many bonds are formed? There are total 4 bonds. Okay, how many bond pair electrons? 8. So can I say it is what? 8 by 2. This is again equal to what? 4, and hence it has a +2 charge. Between this sulfur and oxygen, it is having a what? +2 charge. Okay, clear? Similarly, third one. Talking about the third one, right? So again it is what? Oxygen, it has valence shell of 6 electron. It has 6 electron in the valence shell, right? How many lone pairs? There are 3. That means 6 electrons, right? And then what do you say? How many bonds is it is formed? Only one bond. Or how many bond pair? There are 2. So it is 2 by 2. That is what? 1. 6 minus 6 is 0, and minus 1. So this is what? Minus 1. So minus 1 with symmetry, this is minus 1, and hence minus 1 plus 2. This is 0, no charge. This is 0, no charge, right? Minus 1 plus 2. Again the entire molecule is what? Neutral. That is equal to 0. That's it, Vanshika. Absolutely right. The first one is 0. Welcome to the class. Okay, clear? So yeah, this is one of the concept. If you want to try one more, let us try this thing. Oxygen. As a matter of fact, I want to know the formal charge. Okay, I want to know the formal charge on this. That is this particular oxygen atom. Okay, that is this particular oxygen atom. How to do this thing? As simple as that. It's very simple. If you get the answer, please comment it in the chat box. If not, let us discuss. Oxygen. How many? What is the valence shell electron over here? Can I say valence shell electron is 6? How many lone pairs are there? There is only one lone pair. That means 2. Right? Yes. And how many bonds it has formed? 3. 1, 2, 3. That is 6 electrons. 6 by 2 is again 3. That is equal to +1. And in ozone, if you remember, it carries a positive charge over here, and this carries a negative charge over here. And since the coordinate bond is formed by the second period, we do not represent coordinate bond. We convert it into a single bond, that is covalent bond, and then represent the charges. And now if you calculate the formal charge of this, you will get, what you will get is what? What you are going to get it? You are going to get as -1. You will get the formal charge as -1. Clear? Sure? Perfect, Vanshika. That's absolutely right. Okay, so that was all about formal charges. Now, formal charges have been discussed. Let us start with Fajan's rule. फजान्स रूल का बहुत सिंपल सा कॉन्सेप्ट है गाइस, इट्स अ वेरी सिंपल कॉन्सेप्ट. ये बस इतना बोलता है कि कोई भी बॉन्ड ना कंप्लीट आयनिक है ना कंप्लीट कोवैलेंट है. Hence, Fajan's rule is used to know what is the covalent or what is the amount of covalent character is present in an ionic bond. Ionic bond में कितना covalent character present है वो ये बताता है. ठीक है, there are two extreme bonds, one is ionic and one is covalent, and none of the bond is completely ionic and none of the bond is completely covalent bond. And Fajan's rule is used to know what is the percentage or what is the amount of covalency in ionic bond. ओके, सो 2-3 चीज़ें हम यहाँ पे पढ़ेंगे, 3 चीज़ें एज अ मैटर ऑफ फैक्ट. द फर्स्ट वन इज पोलराइजिंग पावर, द सेकेंड वन इज पोलराइजेबिलिटी, एंड द थर्ड वन विल बी पोलराइजेशन. ओके, पोलराइजेशन, polarizing power and polarizability. So let us discuss. See, we are discussing ionic compounds, right, or ionic bonds or the covalent character in ionic bonds. So let us see, there are bonds formed between these two ions. Ideally, if there is no polarization, there is an cation over here, there is an anion over here, and they are formed a bond, and this is this maximum closest distance that we have discussed at the first session. इससे ज़्यादा close नहीं आ सकते वो, right? So if there is no polarization, this will be as symmetrical as possible. This will be what? As symmetrical as possible. But this is certainly not true. Why? Because a cation will have more effective nuclear charge. The moment an atom forms cation, its effective nuclear charge increases. Similarly for anions, if I make it Z effective, its effective nuclear charge decreases, right? If effective nuclear charge increases, that means it has a more tendency to pull the electron toward itself. Whereas if effective nuclear charge decreases, can I say that the electronic cloud are more free or not in control of nucleus? That means it cannot be controlled. Okay, and hence what will happen is this cation will use its effective nuclear charge to distort the electronic cloud of an ion. To distort what? The electronic cloud of an ion, and in spite of being symmetrical, it will follow this thing. It will have something like this. The ion will get distorted. The ion will get distorted, and this phenomena of distortion of an ion by a cation is known as polarization. Is known as what? Polarization. And I am going to abbreviate this thing by P. Okay, and this polarization is directly proportional to covalent character. Is directly proportional to what? Covalent character. इसको हम आप से बोलेंगे CC. ठीक है. The effect of the cation that has been shown by distorting this anion is known as polarizing power. Is known as what? Polarizing power. Whereas anion is known as polarizability. It is known as what? Polarizability. Okay, and इसको मैं abbreviate करूँगा PZ से. Okay, so there are 3 things: polarization, polarizing power, and polarizability. Polarization is directly proportional to what? Covalent character, and polarization is also directly proportional to polarizing power and polarizability. So this is the structure that it should look like. Okay, so this is what? Polarizing power. This is what? Polarizability. जितना ये दोनों ज़्यादा होंगे उतना अच्छा क्या होगा? कोवैलेंट कैरेक्टर होगा. एंड टू मेक इट मोर, कैन आई से Z effective? Z effective should be more, and over here what should be less? Z effective should be less, right? Clear? And Z effective करना है तो चार्ज इंक्रीज कर दो. Charge should increase. Over here also charge should increase. ठीक है, more the charge on the ion, more is the what? More the charge on the cation. Here I have to take more the charge on the cation, and here more charge on the anion part. ठीक है, and hence what will happen? Polarization will increase, and hence covalent character will increase. Okay, so that is the particular case. Okay, and this phenomena that has been happened is known as what? Polarization. So basically they will get merged, and there will be some sharing of electrons. Some electron cloud will get shared, and this is known as what? Polarization or covalent character, that we can understand with what? Fajan's rule. Proceeding further, as I said, smaller the extent of polarization, okay, higher is the ionic character. याद रखना, अगर extent polarization कम हुआ है तो ionic character ज़्यादा होगा, because polarization is directly proportional to covalent character but inversely proportional to ionic character. So smaller p, higher ionic character. higher P, smaller ionic character. Vice versa is also true. Vice versa is also true. Higher P, higher covalent character, lower P, lower covalent character, right? और पोलराइजेशन बहुत से चीज़ों को अफेक्ट कर देता है गाइस, ठीक है. इट्स मेल्टिंग पॉइंट, बॉइलिंग पॉइंट, इंटेंसिटी ऑफ कलर एंड व्हाट नॉट. बट ठीक है, अभी के लिए फिलहाल इतना काफ़ी है, ठीक है. नेक्स्ट वन, what are the favor, okay, what are the covalent character? Covalent character has been favored by some of the important things. The first one is small size of cation, जैसे मैंने बोला, ठीक है. इफेक्टिव न्यूक्लियर चार्ज ज़्यादा होगा, दैट मीन्स व्हाट, साइज कम हो जाएगा. लार्ज साइज ऑफ अनायन, अनायन जितना बड़ा होगा उतना बेटर है, ठीक है. हायर cation to anion ratio, okay, higher charge, not ratio, higher the charge of cation to anion ratio. And the last one, cation of pseudo noble gas configuration. Pseudo noble gas configuration क्या होता है, जिसके वैलेंस शेल में 8 इलेक्ट्रॉन हो. लाइक फॉर एन एग्जांपल सोडियम आयन एंड कॉपर आयन. Sodium ion and copper ion, you always remember that since it has 8 electron in the valence shell, it is like 2 8 8 18. Okay, it has 18 electron in the valence shell and it has only 8 electron. So pseudo cations or pseudo noble gas configuration, okay, the cation which has pseudo noble gas configuration will have more ionic character, okay, it will have more polarizing power as well. Clear? Sure. And that's why copper compounds are more of a covalent as compared to sodium. Clear? So yep, we have also discussed Fajan's rule. Now talking about resonance. Okay, now talking about resonance. Why resonance has been used? क्यों करते हैं हम रेजोनेंस, या रेजोनेंस का इंपॉर्टेंस क्या है? रेजोनेंस वी बेसिकली डिस्कस अबाउट रेजोनेंस व्हेन वन लुईस सिंबल इज नॉट एबल टू एक्सप्लेन ऑल द प्रॉपर्टी ऑफ अ मॉलिक्यूल. when one Lewis symbol is not able to explain all the properties of the what molecules, then what we use is what resonance. याद रखना, जब भी कोई भी एक स्ट्रक्चर Lewis symbol, कोई भी एक Lewis symbol सारे प्रॉपर्टीज को एक्सप्लेन नहीं कर सकता, तब हम क्या यूज करते हैं? रेजोनेंस यूज करते हैं. क्लियर? श्योर. लेट अस स्टार्ट. ओके, एंड रेजोनेंस सबसे पहले ओजोन मॉलिक्यूल में हम चेक करते हैं. सो लेट अस डिस्कस दिस थिंग. देयर आर सम पैरामीटर्स दैट आई हैव सेट. द डिस्टेंस बिटवीन O1 and O2 is L1, okay, and O2 and O3 is L2. The energy, the bond dissociation energy is E2 over here, E1 over here, and here it is E2. Okay, and इसी का एक रेप्लिका बनाया मैंने. What I have just done is यहाँ का पाई बॉन्ड यहाँ पे शिफ्ट कर दिया गया. So these are the two possible structure before resonance. These are the two possible structure that anyone can think, right? Let us see. What is the bond order between O1 and O2? It is 2. What is the bond order between O2 and O3? Bond order basically क्या होता है? Number of bonds between any two atoms. कोई भी दो एटम में मॉलिक्यूल का बॉन्ड ऑर्डर नहीं होता, दो एटम्स के बीच में बॉन्ड ऑर्डर होता है. बॉन्ड ऑर्डर इज ऑलवेज बिटवीन टू एटम्स. इट इज ऑलवेज बिटवीन टू एटम्स, नॉट बिटवीन द मॉलिक्यूल्स. ओके, मॉलिक्यूल का बॉन्ड ऑर्डर कभी नहीं हो सकता. O2 और O3 के बीच में सिंगल लाइन, दैट मीन्स वन बॉन्ड. सो व्हाट इज एक्सपेक्टेड? इट इज 2 and 1. It is 2 and 1. Okay, second one, what is the bond length? If I talk about the bond length between O1 and O2 is L1, whereas O2 and O3 is L2. हमें पता है बॉन्ड ऑर्डर बढ़ेगा तो बॉन्ड लेंथ कम हो जाएगा. ठीक है, ये हम आगे भी डिस्कस करने वाले, बट आई होप यू नो दिस थिंग एज वेल. एज बॉन्ड ऑर्डर इंक्रीजेस, बॉन्ड लेंथ डिक्रीजेस, राइट? सो विद दिस केस कैन आई से दैट L2 is greater than L1. L2 is greater than N1. आगे बढ़ते हैं. बॉन्ड एनर्जी, जैसे ही बॉन्ड लेंथ बढ़ गया, बॉन्ड एनर्जी क्या होगी? कम हो गई, राइट? सो कैन आई से दैट E1, अगर बात करें E1 की एंड बात करें E2 की, तो किसकी एनर्जी ज़्यादा होगी? कैन आई से दैट E1 विल बी ग्रेटर देन E2, राइट? ये सारे एक्सपेक्टेड है. दिस आर ऑल व्हाट एक्सपेक्टेड, बट एक्चुअल इज समथिंग डिफरेंट. एक्चुअली जब ओजोन मॉलिक्यूल को एनालिसिस किया गया विद रिस्पेक्ट टू स्ट्रक्चर, इट वाज फाउंड दैट इट हैज़ bond order of 1.5, which is exactly average of these two orders, bond order. Okay, then its length was found to be L1 is equal to L2. Last but not the least, the energy was also found out to be what? E1 is equal to E2. ये पता चला. Hence what people thought was कि this result what they are getting is the average of these two structure. And they ultimately came to a final decision that ozone molecule will be look something like this. Okay, bond order 1.5 means what? Not a complete bond. Okay, and they term this thing as resonance hybrid or real hybrid structure, whereas this whereas this are known as resonating structure, RS, whereas these are known as what? Resonating structures. And resonating structures are a hypothetical structure, they do not exist. Okay, resonating structure does not exist, whereas real hybrid is an actual structure and it exists. Please remember this thing. Okay, clear? And real hybrid will always have less energy and more stability as compared to what? Resonating structure. Whenever you draw a resonating structure, the care must be taken that they are almost of same energy. There should not be a huge energy gap between the resonating structure. If there is a resonating structure with a very high energy and very less stability, that resonating structure is not at all possible. Okay, so yeah, that's all concept is there, whatever I've just said. And now, what is the note point? First of all, resonating structure. Okay, resonating structure are imaginary and hypothetical, that I have already discussed. Okay, and which does not exist. Real resonance hybrid is a real structure which actually exists. Resonance is been represented by what? It's been represented as what? Double-headed arrow, and hence resonance can be easily summarized as what? This particular structure. Okay, it is nothing but the average of all the resonating structure that comes. One more thing that you have to remember is the position of the atoms. Okay, this is the conditions for writing about resonating structure. The position of the atom should not change in the resonating structures. मतलब ऐसा नहीं कि आप एक एटम को उठा के कहीं और पे कर दो, ये गलत है. ठीक है, इन रेजोनेटिंग स्ट्रक्चर द पोजीशन ऑफ एटम्स एंड द पोजीशन ऑफ इवन सिग्मा इलेक्ट्रॉन्स विल रिमेन द सेम. ओनली पाई इलेक्ट्रॉन्स और लोन पेयर ऑफ इलेक्ट्रॉन विल चेंज इट्स पोजीशन. Contributing structures should differ only in the positions of electrons. As I said, sigma electrons should not be changed, only pi or lone pair electrons. Let me write over here, pi or lone pair of electrons. Okay, and the number of unpaired electrons at any point of a time should be the same in every resonating structures. Okay, last but not the least, the energy of contributing structure should be nearly the same one. As I said, ज़्यादा energy difference नहीं होना चाहिए. Clear? Proceeding further, resonance energy, the difference in the energy of resonance hybrid and the most stable resonating structure or most stable contributing structure. Okay, clear? So basically this is the difference. The difference over here is known as what? Resonance energy. Okay, suppose there are resonating structure like RS1, RS2 and RS3. These are resonating structure and there is one real hybrid structure. Okay, and in energy order, this is energy. Okay, this is energy over here. So here it is RS1. Okay, here it is RS2. Here it is RS3, and here it is RH. Okay, so the resonance energy RE, resonance energy will be equal to RS3 minus RH. The most stable resonating structure, the difference between the most stable contributing or resonating structure as compared to what? Real hybrid structure. Clear guys? Sure. So this is what resonance energy is all about. Okay, clear? So up, formal charge done, Fajan's rule done, resonance done. Coming upon to bond parameters. Let us start with bond parameters. There are 4 bond parameters that we need to discuss. The first one is bond order, bond angle, bond length and bond energy, in which I am just going to discuss this one because this is very important. Rest are very easy and you can easily know it, and the relationship between them is also very important. Bond order is directly proportional to bond angle, which is directly proportional to bond energy, and which is inversely proportional to what? Bond length. So if you understand one, you can identify all. What is bond order? It is the number of bonds between given any 2 atoms. Bond order is not applicable for the entire molecule, it is for the atoms, just for 2 atoms. What is bond angle? It is the angle formed by 2 atoms which are directly bonded to what? The central atom. Okay, that is what bond angle. What is bond energy? It is the amount of energy required to break any particular bond. And what is bond length? The distance between the 2 atoms. Okay, the maximum closest distance between any 2 atoms that we have already discussed. Let us discuss bond angle a bit in detail. Let us discuss a bond angle a bit in detail. That is, first, how to know bond angle. The first one, check the hybridization of central atom. Okay, check the hybridization of central atom or the percentage of S character. As hybridization of central atom increases, the bond angle decreases. Okay, like from sp to sp2, can I say that hybridization in terms of number of atoms getting mixed, has increased, right? So see, its bond angle has decreased. If we'll increase it more, it will further decrease. If we'll increase it more, it will further decrease. So it will keep on decreasing as the number of orbitals getting mixed. So this is the first thing. As the percentage of S character is nothing but the hybridization keeps on increasing, its bond angle keeps on increasing. Clear? Then the next question arises, what if the central metal atom has the same hybridization, right? Then check for the lone pairs. Then check the lone pairs. If more number of lone pairs are there, that means the bond angle will be even less. For an example, this. So if hybridization is same for central atom, then bond angle decreases with increase in lone pair on central atom. Best example, see, CH4, 0 lone pair, 1 lone pair and 2 lone pairs, right? Hybridization is the same. See the bond angle, it keeps on decreasing. And as a matter of fact, please remember this bond angle. Please remember this bond angle for CH4, NH3 and H2O. Clear? Sure. And this is the where I have written what bond order. I hope this segment is also visible. If not, the bond angle is this order. Clear? Sure. Now what if hybridization is also same and the number of the number of lone pair is also same. Hybridization is same and the lone pair is also same. Then what do you have to check? Then you have to check the electronegativity and size of central metal atom and central atom as well as the side atoms. So if the hybridization of lone pair electron and the central atom is the same, okay, if the hybridization and lone pair on central atom is what? Same, then electronegativity of central atom and the side atoms must be checked. In that first case, first always check the electronegativity of central atom. As electronegativity of central atom increases, it increases the bond angle as well. As electronegativity increases, it increases the bond angle as well. The best example over here, see, nitrogen, phosphorus, arsenic, barium, antimony. Okay, clear? So as electronegativity increases, can I say that down the group electronegativity decreases and hence nitrogen is what? Highly electronegative as compared to all this, hence it will have more bond angle. See. Okay, clear? Then again water, oxygen is highly electronegative as compared to sulfur, selenium and tellurium, and that's why it will have more bond angle. Clear guys? Sure. So this is the case. Now what if the electronegativity is also same? What if the electronegativity of central atom is same? Then check the electronegativity of the side atoms. Okay. So if electronegativity of central atom is same, then increase in electronegativity of the side atom decreases the bond angle. It decreases the bond angle. Another way you can also say that if electronegativity is less, its size is more. So increase in size decreases the increase in size of the side atom. It decreases the what? Decreases the what? Bond angle. Like phosphorus, chlorine, bromine, iodine, right? Electronegativity of side atoms, okay, of side atom is inversely proportional to bond angle. That means less the electronegativity, more the bond angle. Out of fluorine, chlorine, bromine and iodine, iodine is less electronegative and more in size. That's why it will have more bond angle as compared to ore. Okay, that's the same thing I have written over here and with the example. Clear guys? Sure. Perfect. So this is all about what? Bond angle and bond length and if bond order, bond angle, bond energy and bond length is somewhat will be revolving around this. The only reason I have discussed this thing because in last 4 to 5 years or last past 10 years there are almost 4 to 5 questions on bond angle. That's why it is important and there are too many twists and turns in bond angle itself. Okay, clear? Thumbs up. So we have discussed this. Let us start with Sidgwick and Powell. It's very simple. Sidgwick and Powell theory is very simple. What they said, the electron combines, okay, with an atom in such a way that, okay, they'll form a bond, but their bond is oriented in such a way that there should be a least repulsion. There should be what? A least repulsion. Okay, that's the only thing that they have said, and that was one of the problematic statement as well. So let us start with Sidgwick and Powell theory. Talking about Sidgwick and Powell theory, they say that bond pair electrons and lone pair electrons are equivalent. This is the biggest mistake what they did. Okay, they said everything right, but the repulsion or the consider that bond pair electrons and lone pair electrons are what equivalent. That means the repulsion between the bond pair and the lone pair and the lone pair bond pair will be the same, but that is not actually the case. Is lone pair will have more repulsion. That was been cleared in VSEPR theory. Take it? Clear? So yeah, according to them they gave this particular table. According to them they give this particular table. If there are only 2 electron pairs, that means only 2 side atoms. Okay, that means only what 2 side atoms, like suppose A is a central atom and B's are the side atoms. So they can be arranged in a linear way. They can be arranged in a linear way like this. Okay. Okay, so its structure is what linear. If there are 3, it becomes triangular planar. If there are 3, it becomes what triangular planar, something like this. Okay. So like a Mercedes-Benz structure. Okay, clear? If it is 4, then it will have a tetrahedral structure. Okay, so I'll try to draw the structures. Every structure is possible. Okay, if it is 5, it forms trigonal bipyramidal. So trigonal bipyramidal can be drawn in this way. Okay, so yeah, a triangular base, first of all, a triangular base like this, 1 atom at the top and 1 atom at the bottom. So it looks something like this. Okay, clear? Talking about octahedral again, the only change is, in spite of a triangular base, it will have a rectangular or trapezoidal base. Okay, and it will look something like this. One oxygen at the top, or not oxygen, 1 atom at the top and 1 atom at the bottom. So these are the three, these are some of the cases where you have to represent. This is the least one that I don't think so it will be coming. In spite of 4 side, it will have a pentagonal shape. Okay, pentagonal bipyramidal, 5 atoms at the bottom and 1 at the top and 1 at the bottom one. Okay, so this is what they said. But yes, the final theory was given by what? VSEPR theory. The final theory was given by what? VSEPR theory, and this is very important. Talking about VSEPR theory. Okay, VSEPR theory has some postulates that you should know. Okay, first of all, the shape of the molecule is determined by the repulsions. Okay, it is determined by the repulsion between all the electron pair present in the valence shell of electrons. Means be it bond pair or lone pair, they will do some repulsion, and depending upon the repulsion will define the shape or the geometry of the molecule. Second, a lone pair of electron takes more space around the central atom than the bond pair. That means you should always place lone pair where bond angle is more. Okay, so याद रखेंगे हम इस बात को, since lone pair occupies more space. Okay, since lone pair occupy more space, that means the lone pair is always placed in that particular bond or that particular position where the bond angle is what? Maximum. Okay, and so does the double bond. Not only lone pair, even double bond is, since double bond also require more space, that's why double bond and lone pair are placed at that particular angle where the bond angle is more, or that particular side where the bond angle is what? More. So please make a note of it. Then order of repulsion, please remember this order of repulsion as well. Lone pair will have maximum repulsion and bond pair will have minimum repulsion. Okay, and the last one, the presence of a lone pair on the central atom causes distortion, slight distortion. I hope you are able to see this thing. Okay, it causes what? Slight distortion, and its geometry changes into shape, So these are some of the postulates. There are more, but yes, these are some of the postulates that is really very important and you should know about it. Okay, now let's proceed further. The order of repulsion between the triple bond is more, triple bond is more, then double bond is more, and the single bond is low. Okay, so this is the order of what? Repulsion. Multiple bonds between two atoms counts same as single bond, because since this covalent bond are directional in nature, so irrespective of how many bonds are there in a particular direction, it will be considered as a single direction itself. It will be just considered as a single direction because they are directional in nature. तो एक से ज़्यादा अगर bond उस direction में आ भी रहे हैं तो we'll still consider it as a one bond. Okay, perfect. Now talking about geometry and shape, the geometry is what? A symmetrical nature. Geometry is what? A symmetrical structure. Okay, whereas shape is what? Whereas shape is what? An unsymmetrical structure. Geometry is symmetrical structure, whereas shape is what? An unsymmetrical structure. This is the first case that you should remember. अब जैसे जैसे हम आगे बढ़ेंगे, okay, there are something that I am going to use. A, you will understand wherever I write it A, it is a central atom. It will be what? A central atom. Talking about B, B will be what? The side atoms. The side atoms. Okay, and talking about L, it will be lone pair, presence of lone pair. So this is the terminology that we are going to use. A is central atom, B is side atoms, and L is what? Lone pair of electrons. Okay, and always remember the minimum electron pair. The one more thing that I am going to use over here is electron pair, and electron pair, in some book it is also written as steric number. Okay, that has to be minimum 2. And 2 means what? It consists of a bond pair plus lone pair. They both combine to give you what? 2. Now it can be 1 1 or only 2 1. Okay, and bond pair 2 means what? There are 2 bonds present. There are 2 bonds present. So let us get started. The first one where electron pair is 2. Okay, and whenever electron pair is 2, its hybridization is was sp. And yes, हाइब्रिडाइजेशन साथ में कवर करते चलूँगा. सो एंड में हम हाइब्रिडाइजेशन डिस्कस नहीं करेंगे, हम अभी डिस्कस करेंगे हाइब्रिडाइजेशन. ठीक है. एंड ओवर हियर 2 मीन्स व्हाट? इट हैज बॉन्ड पेयर प्लस लोन पेयर. And the type that I have taken over here is AB2. That means no lone pair. That means lone pair tends to 0 over here. And logical भी है. अगर lone pair 1 हो गया और एक ही atom बच गया, so can I say that suppose this is A, central atom, this is B and lone pair. There is no structure over here, guys. It has to be linear itself. If there is only 2 atoms to be arranged, it has to be always what? A linear structure. Okay, so at least 3 atoms are required, out of which 1 will be central atom and 2 will be the side atoms, and this is the case. Okay, so AB2 can I represent as A, okay, and then B. Why we can say that? Suppose these are 2 bond pairs. Okay, ये जो मैंने लिया है, they both are what? Bond pairs, and they consist of electron, and they are coming close to each other. Okay, they are trying to mix. Can I say that these 2 are negatively charged species, and since these 2 are negatively charged species, they will repel, and they will repel in such a way that they should get the maximum distance between them. So they'll start repelling, and they'll form a 90 degree. Still possibilities are there, they can repel, yes, still possibilities are there, and they'll go to 180 degree like this. Okay, it will go to what? 180 degree, and since it has formed 180 degree, now what people say, sir, it can go beyond that thing, right? So it can again bend. Yes, it is bending. From upside the bond angle is increasing, but from downside the bond angle is still decreasing, and that's why the best angle is what? 180. That's why the best angle is what? 180. So over here the bond angle is how much? 180 degree. Okay, there's something that we need to discuss. Talking about its geometry, it is linear. Its geometry is what? Linear. What about its shape? Shape will only come into the picture when central atom has lone pair. Remember this thing, very important. When central atom has lone pair, then and only then shape will come into existence. Okay, and over here there's the same thing. Its hybridization is sp and its bond angle is 180 degree. And we'll be discussing the same thing in entire session. We'll be discussing geometry, we'll be discussing shape, we'll be discussing hybridization, and we'll be discussing bond angle as well. Okay, so that is electron pair is equal to 2. Now let us discuss electron pair equal to 3. The moment it becomes 3, its hybridization becomes sp2. That means the sum of bond pair plus lone pair, if it is equal to 3 on central atom, that means it will have sp2 hybridization. Now what is the structure AB3? Okay, can I draw structure AB3 as A, and the maximum possible distance is at 120 degree, B, B, and this is 120 degree everywhere, right? Since there is no lone pair on central atom, can I say that geometry is equal to shape, that is equal to triangular planar structure, and the easiest way to remember this thing is Mercedes-Benz. This look like a logo of what? Mercedes-Benz. So yes, you can remember this structure as what? Mercedes-Benz. Okay. What is the hybridization of this atom? sp2. Because 3 bond pair, 0 lone pair equal to 3, that means it's equal to what? sp2. Now we have to place one lone pair. Here there is not a problem where to place lone pair because all the angles are 120 degrees, so you can place it anywhere. Now I'll be placing one lone pair. So B, and there is one lone pair. Can I say that lone pair bond pair repulsion is more? And since lone pair bond pair repulsion is more, they will try to squeeze it. It will try to squeeze the bond angle. Normally it has to be 120, but since the lone pair bond pair repulsion is more, it will try to again bend it. It will try to bend it. That means can I say that this bond angle will be less than 120 degree? The bond angle will be what? Less than 120 degree. Over here, its geometry is triangular planar, but its shape is like a V. If you'll see it, it's like V. Okay, it's like V. Okay, or opposite of A. Okay, it's like AV. So okay, just joke apart, it's like a V shape or bent shape or angular shape. So this is the structure. Clear? Sure. So please try to remember all these things. We are going to apply these things as well. AB4. Okay, AB4. So let me draw the central atom everywhere. A and A. Talking about its structure will look something like this. Okay, its structure will look something like this. B, right? If you can see this thing, it is what? A tetrahedral. It's like a pyramid. How it is like a pyramid? Let me just show you with some light color. Yes, this might do. Now you will be able to see it's a pyramid. It's what? A pyramid where A is at the bottom of it, right? Clear? So it's like a pyramid. To be very specific, it's a prism. Again, there is no lone pair on the A. So can I say its geometry is equal to shape? Its geometry is equal to what? Shape, and its shape is tetrahedral. Oh, sorry. 1 second. Yeah. It is tetrahedral. You have to remember the bond angle. The bond angle is 109 degree 0.28 minutes, approximately equal to 109.5 degree, and its hybridization will be sp3. Why? The total number of side atoms are 4, so that's why it is sp3. S1s plus 3p is again 4, or the bond pair and lone pair. Over here the bond pair and lone pair is equal to what? 4. Now again the bond angle is same at everywhere. There is no point of placing lone pair. You can place it everywhere. So I am placing lone pair over here. So it is B, and B. Right? Now since lone pair, here there is a bond pair repulsion. Here it is lone pair repulsion. So can I say it will try to suppress the bond more, and hence the bond angle over here, will be less than 109 degree 0.28 minutes. It will be less than that. Okay, and its geometry is tetrahedral, whereas its shape is pyramidal. And again its hybridization is what? sp3. Talking about the last one, see, one lone pair, another lone pair, B and B. Its angle will be much less than 109 degree 0.28 minutes, at least less than this, right? And can you see this shape? It's like V shape again. It's like what? A V shape. So can I say that its geometry is still tetrahedral, whereas its shape is V, bent or angular shape. ठीक है, clear, perfect. So yes, this is the particular case over here for AB4. These are the three cases. Okay, talking about AB5. AB5 is very important, one of the important case. Let us try to draw its structure. First of all, let me try to draw its structure properly. So it's something like this. It is something like this. Okay. So it's like triangular base. It's like a triangular base, one coming at the top and one coming at the bottom. So due to this thing AB5, there are some different things involved. This becomes axial bonds. First thing that you have to remember. This becomes what? Axial bond. Right? And this bond becomes equatorial bond. There is something known as axial bond, there is something known as equatorial bond. The bond angle on equatorial is 120 degree, and the bond angle between the axial bond is 90 degree. Now there are two different bond angles. So it is pretty much clear that if you want to place a lone pair, you will place the lone pair at 120 degree, that is on equator. Okay, you will place the lone pair always on equator, not on the axial bond. Second thing that you have to remember, on axial bond you will always place the most electronegative atom. Okay, you will always place most electronegative atom. Please remember this thing as well. Okay, on axial bond you will always place what? Most electronegative atom. Please make a note of that thing as well. Lone pair on equator, double bond on equator, but the most electronegative atom on what? Most electronegative atom on what? On the axial bonds. Okay, what is its geometry over here? Its geometry is equal to shape, and it is triangular, and it is what? Triangular bipyramidal. Okay, triangular bipyramidal. And what is its hybridization? Its hybridization is sp3d. इसका hybridization क्या है? sp3d. That means कितने lone pair and bond pair? Total 5. That means what? 5 orbital will be mixing. एक s है, 3 p है and एक d है. So total is 5. Side atoms भी कितने होंगे? 5 होंगे. ठीक है. So these are some of the way to identify hybridization. Count कर लो lone pair और bond pair कितने. अगर वो काउंट नहीं होते तो कितने साइड एटम्स है वो काउंट कर लो. ठीक है. साइड एटम्स अगर 5 है तो sp3d, 4 है तो sp3, 1s, 3p equal to what? 4. So yes, these are several ways that you can calculate. Okay, clear? So yes, this is what AB5 molecule. Coming upon to the structure of AB4, L, AB3, L2, AB2, L3. Okay, so AB4L. According to this thing, can I say I can place lone pair over here? I can place lone pair over here, I can place lone pair over here, I can place lone pair over here, I can place lone pair. So there are 3 angles, 3 atoms that can consist of what? Lone pair. Okay, so let me draw it. Central atom and central atom. Okay, so central atom बना लिया अपन ने. एक lone pair place करना है, so I am placing lone pair over here. Okay, I am placing lone pair over here. Talking about the bond pairs, these are the bond pairs. One at the top and one at the bottom. Again, its geometry is trigonal bipyramidal, but its shape is seesaw. कैसे सीसॉ? देखो, इसको मैं ऐसे बना दूँ, ए ऐसे है, ये रहा एक बी, ये रहा दूसरा बी, ये रहा तीसरा बी, ये रहा चौथा बी. कैन यू सी? इट्स लाइक अ सीसॉ जिस पे आप खेलते थे छोटे में. ठीक है, लाइक अ सीसॉ. यू आर सिटिंग ओवर हियर, योर फ्रेंड इज सिटिंग ओवर हियर एंड यू आर ऑसिलेटिंग. Okay, and these are the pillars on which this length has been kept. Clear? So its bond angle, talking about its bond angle, it will be less than 120 degree. Bond angle क्या होगा? Less than 120 degree and less than 90 degree होंगे for sure, because lone pair क्या करेगा? अब suppress करेगा. Talking about AB3L, अब 2 lone pair हम place कर सकते हैं. ठीक है, we can place what? 2 lone pairs. So I am placing 1 lone pair over here and another lone pair over here, B B and B. Its shape is T shape. Its place is T shape. देखो कैसे, ये रहा B, A, B और ये रहा एक B. So can I say it's a T shape molecule, AB3L2, right? Bond angle again less than 120 and 90 degree, right? Clear? 3 lone pairs, lone pair, lone pair, lone pair, okay, and B. Now it is exactly linear. It is exactly equal to what? Linear. So its shape is what? Linear shape. Its shape is what? Linear shape. And the bond angle will be approximately equal to 180 degree, but not 180 degree, less than 180 degree, like 140, 150. Because यहाँ पे दो लोन पेयर इसको रिपेल कर रहे हैं, यहाँ से ही एक ही लोन पेयर रिपेल कर रहा है. अगर दोनों तरफ से दो दो होते तो हम प्रॉपर उसको लीनियर मान लेते कि 180 डिग्री होगा, बट यस नियर बाय इक्वल टू 180 बट नॉट एग्जैक्टली इक्वल टू 180 डिग्री. क्लियर? श्योर. सो दिस इज sp3d. टॉकिंग अबाउट sp3d, सॉरी sp3d2. ओके, ab6 सेंट्रल एटम पहले बना लेते हैं सब जगह. ए ए ए, ठीक है. अब साइड एटम्स प्लेस करना स्टार्ट करते हैं. ओके, सो ये इस तरह से दिखेगा. Can you see it? It has a rectangular और square base. एक स्क्वायर बेस होगा, उसके ऊपर एक और उसके एक नीचे एक. ठीक है, क्लियर. अब इसमें से लोन पेयर, अगर इसका मैं बॉन्ड एंगल तुमसे पूछूं तो व्हाट विल बी द बॉन्ड एंगल? ईच एंड एवरी बॉन्ड एंगल इज 90 डिग्री. ज्योमेट्री क्या है इसका? ज्योमेट्री इज इक्वल टू व्हाट? शेप. ज्योमेट्री सबका ही सेम होगा, बट शेप सबका क्या होते जाएगा? डिफरेंट हो जाएगा. तो ज्योमेट्री इज इक्वल टू व्हाट? शेप. एंड शेप इज इक्वल, ज्योमेट्री एंड शेप इज इक्वल टू व्हाट? ऑक्टाहेड्रल. शेप इज इक्वल टू व्हाट? ऑक्टाहेड्रल. एंड हाइब्रिडाइजेशन क्या है इसका? sp3d2. क्लियर? श्योर. सो यस, आगे बढ़ते हैं. एक लोन पेयर प्लेस करना है, तो यहाँ पे एक मैं लोन पेयर प्लेस कर देता हूँ. बी 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 एंड बी, like this, and its shape is what? स्क्वायर पिरामिडल. शेप क्या है इसका? स्क्वायर पिरामिडल. ज्योमेट्री अभी भी क्या है? ऑक्टाहेड्रल ही है. ज्योमेट्री स्टिल व्हाट? ऑक्टाहेड्रल ज्योमेट्री. एंड द बॉन्ड एंगल विल बी लेस देन 90 डिग्री. अब बॉन्ड एंगल क्या होगा? लेस देन 90 डिग्री. एक भी रह गया यहाँ पे, ये रहा, सॉरी एक भी रह गया था. ठीक है, देन जस्ट ड्यू टू सिमेट्री आई एम प्लेसिंग वन ओवर हियर एंड वन ओवर हियर. बी बी एंड बी. ओके, नाउ इट्स शेप विल बी व्हाट? स्क्वायर प्लेनार. अब ये कैसा दिख रहा है? स्क्वायर प्लेनार जैसा दिख रहा है. एक लोन पेयर ऊपर, एक लोन पेयर नीचे. दैट मीन्स अब उनका रिपल्शन क्या होगा? एग्जैक्टली इक्वल हो जाएगा. एंड एग्जैक्टली इक्वल हो गया तो वापस से बॉन्ड एंगल क्या हो जाएगा? 90 डिग्री पे आ जाएगा. क्लियर? श्योर. गॉट इट. सो यस, दिस आर सम ऑफ द केसेस रिलेटेड टू व्हाट VSEPR थियोरी. एंड VSEPR थियोरी के साथ साथ मैंने हाइब्रिडाइजेशन भी तुम्हें बताया है कि स्ट्रक्चर्स के साथ उसकी हाइब्रिडाइजेशन भी पता करो. काउंट द बॉन्ड पेयर एंड लोन पेयर ऑन द सेंट्रल एटम एंड देन यू विल गेट द व्हाट? हाइब्रिडाइजेशन. क्लियर? श्योर. परफेक्ट. आगे बढ़ते हैं, अप्लाई करते हैं सारी चीज़ों को. जो भी चीज़ें पढ़ा अप्लाई करते हैं. लेट अस स्टार्ट विद द फर्स्ट कंपाउंड, दैट इज XeO2F4. बेस्ट तरीका बता रहा हूँ आइडेंटिफाई करने का. सेंट्रल एटम आइडेंटिफाई कर लो. मेरे हिसाब से हीलियम है. हीलियम के पास टोटल वैलेंस शेल इलेक्ट्रॉन कितने होते हैं? 8. और मुझे पता है हाइब्रिड मिक्सिंग के लिए वही आने वाले, या VSEPR थियोरी में वैलेंस शेल इलेक्ट्रॉन ही पार्टिसिपेट कर 8. कितने ऑक्सीजन बॉन्ड कर रहे हैं? कितने ऑक्सीजन बॉन्ड कर रहे हैं? 2. एक ऑक्सीजन अगर बॉन्ड करेगा जिनॉन के साथ तो डबल बॉन्ड बनाएगा. तो मतलब 2 बॉन्ड करेंगे तो 4 बॉन्ड. दैट मीन्स 4 इलेक्ट्रॉन्स आर गॉन. ठीक है. 1 ऑक्सीजन विल टेक 2 इलेक्ट्रॉन बिकॉज इट फॉर्म्स डबल बॉन्ड. सो 2 ऑक्सीजन विल टेक 4 इलेक्ट्रॉन्स. ओके. फ्लोरीन कितने हैं? टोटल 4. दैट मीन्स वैलेंस शेल इलेक्ट्रॉन कितना हुआ? 0. दैट मीन्स देयर इज नो लोन पेयर. ये कैलकुलेशन के हिसाब से देयर इज नो लोन पेयर ऑन जिनॉन. ओके. व्हाट विल बी द स्ट्रक्चर? और अगर लोन पेयर नहीं है तो ये किस टाइप का हुआ? A 2 + 4 इज व्हाट? 6. AB6 टाइप का हुआ. एंड सिंस इट इज AB6 टाइप्स, कैन आई से दैट इट्स हाइब्रिडाइजेशन इज sp3d2. वन वे ऑफ सेइंग. दूसरा स्ट्रक्चर बना लो. डबल बॉन्ड ऊपर, डबल बॉन्ड नीचे, फ्लोरीन 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 एंड फ्लोरीन. कितने बॉन्ड पेयर है टोटल? 1 2 3 4 5 6 बिकॉज डबल बॉन्ड इज ऑल्सो कंसिडर्ड एज सिंगल बॉन्ड. ओके, तो टोटल 6 है. बॉन्ड पेयर प्लस लोन पेयर, दैट मीन्स इलेक्ट्रॉन पेयर टोटल कितने हैं? 6. अब वापस से हाइब्रिडाइजेशन सेम आ रहा है. व्हाट विल बी ज्योमेट्री एंड शेप? बिकॉज कोई लोन पेयर नहीं है तो ये क्या हो जाएगा? ऑक्टाहेड्रल हो जाएगा. इज इट अ पोलर मॉलिक्यूल? नो, इट इज़ नॉट अ पोलर मॉलिक्यूल, क्योंकि ये इसका ऊपर है, इसका पोलैरिटी नीचे है, एंड दिस फ्लोरीन विल गेट बैलेंस, सो इट इज़ नॉन पोलर. समझ में आ रही है चीज़ें? तो डाइपोल भी आप निकाल सकते हो अगर स्ट्रक्चर मिल गया तो. परफेक्ट. XeO2, लेट अस अप्लाई द सेम कॉन्सेप्ट. जेनॉन के पास कितने इलेक्ट्रॉन्स होते हैं? टोटल 8. 2 ऑक्सीजन है तो कितने इलेक्ट्रॉन लेके जाएंगे? 4. कितने बचे टोटल? 4 इलेक्ट्रॉन्स. डिवाइड कर लो तो कितना मिल जाएगा? 2 लोन पेयर मिल जाएंगे. राइट, तो ये किस टाइप का मॉलिक्यूल हो गया? B2L2, मतलब 2 बॉन्ड पेयर 2 लोन पेयर. दैट मीन्स इलेक्ट्रॉन पेयर कितने हैं? 4. दैट मीन्स इट्स हाइब्रिडाइजेशन इज व्हाट? sp3. राइट, तो स्ट्रक्चर कैसा बनेगा इसका? Xe, लोन पेयर, डबल बॉन्ड हो. किस तरह का शेप है इसका? V शेप या बेंट शेप. क्या ये पोलर मॉलिक्यूल है? येस, इट इज़ अ पोलर मॉलिक्यूल. राइट, बिकॉज ये इस तरह से होगा, ये इस तरह से होगा, एंड दोनों इक्वल एंड ऑपोजिट नहीं होते. लोन पेयर का डाइपोल मूवमेंट ज़्यादा होता है एज कम्पेयर टू व्हाट ऑक्सीजन. सो यस, दिस इज़ वन ऑफ द कॉन्सेप्ट ऑफ हाइब्रिडाइजेशन एज वेल. क्लियर? श्योर, परफेक्ट. नेक्स्ट वन ICl5. अगेन आयोडीन के पास टोटल इलेक्ट्रॉन्स कितने होते हैं? 7. 5 शेयर कर दिए क्लोरीन के साथ, बचे कितने? 2. एंड 2/2 इज इक्वल टू हाउ मच? 1. तो ये किस तरह का मॉलिक्यूल हो गया? B5L. बॉन्ड प्रेस प्लस लोन पेयर टोटल कितने हैं? 6. एंड 6 अभी हमने देखा sp3d2. हाइब्रिडाइजेशन पता चल गया. ज्योमेट्री एंड शेप, ज्योमेट्री अपने को पता है ऑक्टाहेड्रल ही होनी है. व्हाट इज द शेप? लेट अस आइडेंटिफाई ICl5 विथ 1 लोन पेयर. सो I 1 लोन पेयर ओवर हियर, Cl5, Cl एंड Cl. ये किस तरह का दिख रहा है? स्क्वायर पिरामिडल. ओके, ये किस तरह का दिख रहा है? स्क्वायर पिरामिडल. गॉट इट? क्लियर? परफेक्ट. टॉकिंग अबाउट ICl2 माइनस. ओके, इट इज़ व्हाट? ICl2 माइनस. तो I के पास 7 इलेक्ट्रॉन होता है, एक नेगेटिव आया. ओके, एक नेगेटिव आया, दैट मीन्स कितने बच गए? अब कितने बच गए? टोटल कितने हो गए? 8 इलेक्ट्रॉन्स. कितना इलेक्ट्रॉन क्लोरीन के साथ कंबाइंड है? 2. तो टोटल 6. 6/2 इज इक्वल टू हाउ मच? 3. 6/2 इज इक्वल टू हाउ मच? 3. क्लियर? श्योर? सो 3 लोन पेयर. सो B2L3. तो बॉन्ड पेयर प्लस लोन पेयर कितने हैं? 5. तो हाइब्रिडाइजेशन क्या हो जाएगा? sp3d. राइट, ज्योमेट्री अपने को पता है, ट्राइगोनल, बाइपिरामिडल. राइट, बट शेप कैसे पता चलेगा? लेट अस सी शेप. सो 3 लोन पेयर है, 1 2 3, तीनों के तीनों इक्विटोरियल पे आ जाएंगे. राइट, एंड B किधर चला जाएगा? सॉरी, आयोडीन है ये. एक्सट्रीमली सॉरी, दिस इज आयोडीन. सो ये रहा आयोडीन, ऊपर क्लोरीन और एक नीचे क्लोरीन. हैंस इट्स शेप इज व्हाट? लीनियर, समवॉट लीनियर शेप. राइट गाइस? श्योर? क्लियर? So I hope guys you must have understood whatever was discussed in VSEPR theory. Okay, I hope you must have understood whatever we have discussed in what? VSEPR theory. Okay, so what we have discussed in this thing is formal charges is done, Fajan's rule is done, resonance is done, bond parameters is done, Sidgwick and Powell theory is done, and VSEPR theory is also completed. Okay, so yes, it was like the scheduled session was till 2 o'clock, so I have to stop this session. एक जो लास्ट सेशन बच गया है जिसमें हम हाइब्रिडाइजेशन कवर कर ही चुके हैं, VBT, MOT एंड डायपोल मूवमेंट बाकी, दैट आई विल बी कवरिंग इन द नेक्स्ट सेगमेंट वेयर आई विल क्रिएट one short video for chemical bonding in which we'll be just discussing only these 3 things: dipole movement, then molecular orbital theory, last but not the least that we'll be discussing will be what? The VBT. So VBT हो गया, VBT कर लेंगे अपन. हाइब्रिडाइजेशन कर लेंगे, हाइब्रिडाइजेशन हो चुका है रादर, बट थोड़ा बहुत देख लेंगे. देन MOT एंड द लास्ट वन इज द डाइपोल मूवमेंट. जो बच जाएगा टाइम तो विल डेफिनेटली कवर हाइड्रोजन बॉन्डिंग. क्लियर गाइस? श्योर. So yeah, if you have yet not liked this particular video, please make sure that you are going to like the video. और अगर आप नए हैं चैनल पे अभी तक सब्सक्राइब नहीं किया है तो do subscribe our channel, that is Infinity Learn by Shri Chaitanya, so that you should not miss any of the session of this series known as Chuck Day series for NEET 2022 or JEE 2022. Okay, so please लाइक ज़रूर करना, शेयर ज़रूर करना, सब्सक्राइब ज़रूर करना, एंड येस डू नॉट फॉरगेट टू प्रेस दैट बेल आइकन. दैट इज़ रियली वेरी इंपॉर्टेंट टू अस. Thank you so very much guys for joining this session. How do you like the video? Please do comment and let us know through your comment section. If you have any doubts, please post your doubts in the chat box as well. God bless you all guys. Take care, and yes, keep smiling. We are definitely going to meet soon. Take care guys.